Hello, so we're now going to be looking at the maximum and minimum values of quadratic equations. So if any quadratic equation, we said quadratic equations are in the form of x squared plus bx plus c equals to 0. Now, these quadratic expressions can be expressed as, let me take off the 0, you can express them as something like this. And we're going to see how. So we can read off the maximum and minimum value from this. So the first thing, when you're asked to find the maximum or minimum value of a quadratic equation, we're supposed to simplify it. Now, for those that haven't watched the video on solving quadratic equations by completing squares, I'm going to refer you to that video because the concept is going to be mainly coming from that similar concept. Now here we've been given, we're starting with an example, given fx is equals to x squared plus 3x plus 4. Determine the minimum value, stating the value of x for which occurs. Okay, now we're going to say fx is equals to x squared plus 3x plus 4. Now we are going to try to create a perfect square out of this quadratic equation. And now, since here there is no equals to 0 the way it is in a normal quadratic equation, because here this is just fx is equals to this. In a normal quadratic equation, it would be x squared plus 3x plus 4 is equals to 0. And in the video on completing squares, you would see that we would take this 4 to the other side, but in this case we can't because there is no 0. So we have to work out everything here. Now remember, we said the first step is always have to ensure that the coefficient of the x squared term is 1. In this case it's already 1. Okay, now so here, instead of us taking this the other side, we're just going to try and isolate this into like a small bracket. Now we would be working within this. So now here we have 3. Remember we said we pick the coefficient of the x term. In this case it's 3, multiply it by a half, so we get 3 out of 2, then we square it. So now we have this is equals to x squared plus 3x plus this. But now in this case, after adding it, we now subtract it because we've added it here, so we subtract it such that the equation remains unchanged. In completing squares, we would add it to both sides, so that it would still be like it's cancelling out. But now here we add it here, then we subtract it. So now we have now formed our square here. So we pick this x, we pick the sign after it plus, then we pick this 3 out of 2 squared. I'll refer you to that video. Then now we have plus 4 minus, now this becomes 9 out of 4. So we have this is equals to x plus 3 out of 2 squared. Then we can now put that into a calculator. 4 minus 9 out of 4. What do we get? We get 7 out of 4. So this is plus 7 out of 4. This is f of x. Now, when finding the maximum or minimum values, the way we do it is the same. After finding this, you just equate this to 0. The maximum or minimum value always occurs when this is 0. So we can now say fx is going to be equals to 0 plus 7 out of 4. So we'll see that for this case, the minimum, it occurs at 7 out of 4. But now we can find the value of x at which it occurs. So we are going to say for the maximum or minimum value, this is equals to 0. So x plus 3 out of 2 squared is 0. So we square it on both sides. So x plus 3 out of 2 is equals to 0. X is equals to negative 3 out of 2. So that's the value of x for which it occurs. Now let's see a few more examples such that we can get the concept. Okay. So now here we have 2x squared plus 6x plus 9. Now remember we said here we're borrowing a concept from completing square, solving quadratic equations using completing squares. The first thing we have to try and express this as we factorize it into, like, we obtain a perfect square from this. But we say the first thing we always have to ensure that the coefficient of the x squared term is 1. And how we used to do it, we divide through by 2. That was because on this other side we had 0, so we divide everything by 2. But now here we can't. So what do? We have fx is equals to 2x squared plus 6x plus 9. So we'll take out these 2. So we say fx will be, so we take out 2 and we divide everywhere by 2. By 2, 6x out of 2 9. So you realize if you were to bring in this 2, it would go back to that. So now we can have fx is equals to 2 into x squared plus 3x plus 9 out of 2. So now we can work out our equation from the bracket. So remember I told you we bracket this on its own. Then we pick the coefficient of the x term. In this case it's 3. So we come here on our side, work 3, multiply 3 by a half. What do we get? We get 3 out of 2. We square it. So we have here it's equals to 2. We now have to make a bigger bracket. X squared plus 3x. Then now we add this plus 3 out of 2 squared. We now close this bracket plus 9 out of 2. Then we subtract it. We add it and we subtract it. That is the main concept here. Then we have 2 is equals to, we pick the x because now we have formed our perfect square. We pick the x, then we pick the sign after it, which is a plus. Then we bring 3 out of 2. This is squared plus 9 out of 2 minus 9 out of 4. This. So now we have f of x is equals to 2 into x plus 3 out of 2 squared. Then we can now put this onto our calculator. So we have 9 out of 2 minus 9 out of 4. So what do we have? We get 9 out of 4. So this is plus 9 out of 4. So we have this. So we have this is, we open the bracket, we have 2 into x plus 3 out of 2 squared plus, so this becomes 9 out of 2. This is f of x. Remember I said the maximum or the minimum value will always occur when this is 0. So this will be equals 2 into this plus 9 out of 2. So at the minimum here, the minimum point here, it's 9 out of 2. Then now we come and equate x plus 3 out of 2 squared to 0, square root of both sides. We get x plus 3 out of 2 is equals to 0. X is equals to negative 3 out of 2. So we can actually form a point from this and say that it occurs at negative 3 out of 2 comma 9 out of 2. This is the x value. Then we take this as the y value. Okay, so this is the minimum point. Okay, now we have find the maximum value of this and the value of x for which it occurs. So we have this y is equals to 5 minus 2x minus 4x squared. So the first thing is we rearrange this to look like a normal quadratic equation. This plus 5. Then I told you the coefficient of the x squared term should be 1. So how do we do that? We say y is equals to negative 4 into, we divide everything by negative 4 minus 2x out of negative 4 plus 5 out of negative 4. So we have y is equals to, this cancels, we get y is equals to negative 4. This becomes x squared. Minus and minus, we get a plus, but this goes 1, so it becomes plus half. Plus, so this is a minus. Okay, clear this. So this is minus 5 out of 4. Now we from the bracket here, we pick the coefficient of the x, which is a half, multiplied by a half, we get a quarter, we square it. So we now have y is equals to negative 4 into x squared plus x out of 2 plus this, we put a bigger bracket, then now we say minus, then we subtract it such that our equation remains unchanged. So what are we going to have here? We have y is equals to negative 4 into, we bring our x, the sign after it, which is a plus, then we bring this, so we've formed our perfect square out of this. Then now minus 5 out of 4, then when you square this we get minus 1 out of 16. So now what do we have? We have y is equals to negative 4 into x plus a quarter squared. So now when you put that into the calculator, you get negative 21 out of 16. So now we open the bracket. So this is negative 4 into x plus 1 squared plus 21 out of 4. But remember, for the maximum or the minimum value, this is equal to 0. So we have y is equals to negative 4 20 squared plus 21 out of 4. So the value of y is 21 out of 4. Now I want to find the value of x for which it occurs. X plus a quarter squared would be 0. So we find the square root on both sides. Square root on both sides. X plus a quarter is 0. So what's the value of x? Negative a quarter. So you can write it as a coordinate as negative a quarter, comma 21 out of 4. So that is that. Let's look at another. Okay, so now let's look at another example. So here the question says find the minimum values and minimum points of each of the following. So this is what we've been given. We've been given y is equals to 3x squared minus 12x plus 9. So remember we said we always have to ensure that the coefficient of the x squared term is 1. And how do we ensure that? In this case we are going to say y is equals to 3, and we divide everything here by 3. So we say this is minus 12x out of 3 plus 9 out of 3. So what do we get? Y is equals to 3 into x squared minus 4x plus 3. So this is what we have now. We said we try to create a bracket here, since in this case we don't have this being equal to 0. Then we pick the coefficient of the x term, which is 4. In our side, okay, multiply it by half, we get 2, we square it. This is what we have. So we're now going to say y is equals to 3 into x squared minus 4x plus 2 squared, then plus 3 minus 2 squared. This 2 squared we added, we're now subtracting it. So we now have y is equals to 3 into, now here we are completing squares, so we are going to pick x, then the sign just after it, which is a minus, then we pick this, which is 2, this squared plus 3 minus 4. So what do we have? Y is equals to 3 into x minus 2 squared. So this is 3 minus 4, and 3 minus 4, negative 1. So now we have y, we are going to open the bracket, y is equals to 3 x minus 2 squared minus 3. So for the minimum, y, this x minus 2 squared will be 0. Find the square root on this side. So x minus 2 is 0. So x is 2. So then I also come and find the value of y. 0 squared minus 3. So y is equals to negative 3. So these are the values. Then the point will be 2, comma, negative 3. So now let's look at the case for repeated or equal roots. Now this is the general quadratic formula from the formula we use for solving quadratic equations, and from our video on completing squares you saw how we generate this formula. And so now we are seeing, so before we go further, let's first let me first explain something here. So the general quadratic formula is x is equals to negative b plus or minus square root of b squared minus 4ac out of 2a. Now when you look at this expression, this entire expression, and sorry, this works for any quadratic equation in the form of x squared plus bx plus c is equals to 0. Now in this, when you look, you're going to realize that I'm going to explain why, but this is like what determines the nature of our answer and how. So here, let's see. If b squared minus 4ac is greater than 0, that means if it's like a positive number, for example 20 or anything above 0, we are going to get real. Okay, so we see that so we see that for any quadratic equation, if b squared minus 4ac is greater than 0, then we are going to have real unrepeated roots. If b squared minus 4ac is less than 0, we are going to have imaginary unreal roots. What do I mean by this? If for any number to be less than 0, that means it's a negative. So it's like we have square root of negative 4. So here we don't get real roots, we get imaginary roots. But now if b squared minus 4ac is equals to 0, we get real repeated roots, and this is a condition that we should all walk away with. B squared minus 4ac is equals to 0. we get real repeated roots. Okay, so now let's look at an example here. So the general quadratic formula is x is equals to negative b plus, so here there's a minus, plus or minus b squared minus 4ac out of 2a. So now solving this by factorization method, this a is 1, b is 6, c is 9. So sum b should be 6. So for those who are not understanding, you can watch our video on solving quadratic equations using the factorization method. So you get this, then we also get for the negatives. So we have this. So the number that when you multiply gives you 9, but when you add gives you 6 is 3. So we have x squared plus 3x plus 9 is equals to 0. So this is x into x plus 3, and this is x plus 3. Here there is 3 is equals to 0. So we have x plus 3 into x plus 3. This is equals to 0. So we're going to realize we're going to have our roots as x is equals to negative 3 or x is equals to negative 3. So this is a repeated root. But now let's prove it with our formula. We said any repeated root, and by repeated root we mean that the root is the same like here, negative 3 and negative 3. So this is the condition we said. But what is our b here? B is 6. 6 squared minus 4 into this into 9. This is 36 minus 36, and the answer is 0. So this satisfies the condition that we had talked about. B squared minus 4ac is equals to 0. So this is a condition that I want us to have in our mind anytime the question says a quadratic equation has. Okay, so let's look at these two examples from what we've learned from real repeated roots or equal roots. So here the question says determine k if the equation this has equal roots. So this is our equation, 4x squared minus 8x plus k is equals to 0. So what is a? A is 4. What is b? B is negative 8. Never forget to carry the coefficient. C is k. But the question has said has equal roots, and we've said for any quadratic equation to have equal roots, b squared minus 4ac is equals to 0. So here we have b is negative 8 squared minus 4 into 4. And what is c? C is k. This is equals to 0. So we end up having 64 minus 16k is equals to 0. So we end up having 16k is equals to 64. Divide through by 16, divide through by 16. Our value of k is 4. So we've solved this just by using this condition for a quadratic equation to have equal roots. Okay, so now let's look at our second example. Given that the quadratic equation this has equal roots, show that this is equals to this. So the condition, we have to remember that if any quadratic equation has equal roots, we have to remember our condition. But now let's first quote what is a. A is 1 plus m squared. What is b? B is 2mc. What is c? C is c squared minus q squared. And what was our condition? B squared minus 4ac is equals to 0 for any equation that quadratic equation that has equal roots. So here what we have, this is 2mc squared minus 4 into 1 plus m squared into c squared minus q squared. This is equals to 0. Now the easiest way we can do this, we simplify this in our side work because we don't have so much space there. So 1 plus m squared into c squared minus q squared. So 1 into c squared minus q squared plus m squared into c squared minus q squared. So this is c squared minus q squared plus m squared, c squared minus m squared, q squared. So this is what we have. So meaning here we have 4m squared c squared minus 4 into c squared minus q squared plus m squared c squared minus m squared q squared is equals to 0. So here what do we have? We have 4m squared c squared minus 4 c squared plus 4q squared minus 4m squared c squared plus 4m squared q squared is equals to 0. So this goes with this. Okay, so now we have a negative 4c squared plus 4q squared plus 4m squared q squared is equals to 0. So now all we are left to do is factorization. So we can divide through by 4. We end up having negative c squared plus q squared plus m squared, q squared is equals to 0. So when you make c squared the subject, will have c squared is equals to q squared plus m squared, q squared. So here c squared will be equals to, factorize out q squared, 1 plus m squared. Then we find the square root on both sides. So what do we have? C is equals to q into root of 1 plus m squared. So this is how we've been able to prove this using the condition. So you can get very many other proofs, but you just have to know what condition we need for here. For equal roots, for any quadratic equation have equal roots, b squared minus 4ac is equals to 0.